In this video, we're going to look at skills needed to solve inequalities and graph their solutions. So here's our first example. Now, if you're good with solving equations, we're basically using the same skills that we used for that. We're just adding a layer in terms of graphing it and thinking about what kind of solutions there are. Normally, when we solve an equation, we'll get things like x equals 4 or x equals 0. For inequalities, we're going to have a whole set of solutions that are possible because we're talking about less than or greater than or less than or equal to, so forth. Okay, so first example here, we're just going to solve it like we've been solving equations. So we're going to be subtracting 8 from both sides in this equation. So subtract 8 to get x isolated. Okay, so we'll show our work here. We got negative 3x is greater than negative 3. We'll rewrite the inequality here. Now we have to be careful on this next step because we have a negative next to x. So anytime we divide by a negative or multiply an inequality by a negative, we need to flip the direction of the inequality. So I'm saying it looks like this. So instead of saying x is greater, we'll say x is less than. And this is going to be x is less than 1. Another way you can write this inequality is to write it like this. These both say the same thing. This one I'm reading from right to left, the first one, x is less than 1. The second one I'm reading from left to right, x is less than 1. As we talked about in the last video, we just need to kind of indicate our key point we're looking at on our graph and decide whether we have an open dot or closed dot. In this case, it's just less than. So we have an open dot and its value is less than 1. So things like 0 work, things like negative 1 work, and so forth. So we're going to shade to the left with an open dot. That's it. And of course, you could plug your value back in to the inequality and make sure it works. You could pick any value along this shaded region and test it, see if it worked. For example, let me go and plug one in here for us. So take the original inequality, and instead of having x, we'll put a value in there that's on this shaded region. Just test it. So let's test 0. That's easy to work with. So we have 5 is less than 8. Is that true? Yes, that's true. So we've done our work well here. Second example, same idea, a little more complicated inequality here. Now we can always avoid having to divide by a negative if we think through it correctly. So in this case, I could add 4x to both sides, but what I'll end up with is a negative 2x over here. And then I'll have to flip the inequality at the very end again when I divide by negative 2. So let's avoid all that just as a shortcut. You decide. So if I add 6x to both sides, add 6x to both sides here and rewrite it. So I bring down the negative 3. Don't forget your minus with the 3 is less than or equal to. And notice that now I have a positive x value there. And so I won't have to flip the inequality. Then it's really a matter of preference what you decide to do. And then here we're going to subtract 1 from both sides. And I'm going to rewrite carefully. So I have 2x is greater than or equal to negative 4. And my last step here is to divide by 2. And then rewrite my solution as x is greater than or equal to negative 2. And so again, I'm just going to plot the relevant point there, which in this case is negative 2. And I'm saying x is greater than or equal to negative 2. Remember, I can write that 2 different ways. Make sure you can read it both left to right and right to left. This one's right to left. This one's left to right. Or right to left, I should say. Basically, just be comfortable reading it both directions. All right, now we're saying x is greater than or equal to. So, of course, we're going to need a solid dot in this case. So we'll make our solid dot at negative 2 because it includes negative 2. And greater than or equal to would be to the right. Things like 0 and 2 and so forth. So that's our solution set down here at the bottom. Of course, we could double check and plug in some values that are on this red area into the x's and check it. I'm going to skip that for now and end the video here. Hopefully that helped.